Hi, I'm Andrew from glazertutoring.com, and today I would like to teach you how to balance the reaction of C6H12O6, which sometimes, by the way, is known as glucose, but that's not the only isomer that has that molecular formula. But in any case, glucose plus oxygen gas yields carbon dioxide plus water. This reaction is actually kind of interesting because this is actually how the body metabolizes energy. All right, this converts glucose, and we breathe out carbon dioxide and also water vapor. All right, and we use oxygen to power the process. So with that out of the way, let's start balancing. So here we have now, we're going to place in little spacers to the left of every single compound to represent the locations of where I'm going to place certain values. Okay. The next thing is to keep in mind the principle of just balancing. Whatever is on the left-hand side of the reaction has to balance whatever on the right-hand side of that reaction. Okay. And what I'm going to do is I'm going to start with the first element I see, which is carbon. I want to make sure it's only in this compound, one compound on the left, and I want to check to make sure it's only in one compound on the right, which it is. It's only part of that carbon dioxide. And that's what I want to balance. Okay, I like balancing that. One compound on the left, one compound on the right. So we have 6 carbons on the left. We only have 1 carbon on the right. So I need to place in a 6 here. Remember, you think multiplicatively. In other words, the coefficient multiplied by the subscript will tell you the total number of that particular atom. So you have 6 carbons now on the right, and you also have 6 carbons on the left, because there it's assumed to be, by the way, if there's nothing there, it's assumed to be a 1. Right? So 1 times 6 is simply 6. I'm going to leave it blank for now, though. Next thing I would do is then move on to the next element. So here we have hydrogen. You have hydrogen only in the glucose molecule, we'll assume on the left, and we only have hydrogen in the water molecule on the right. I love that. Let's balance it. How many do you have on the left? You have 12. How many do you have on the right? You have 2. So I have to place a number here, right? A number of 6. You want to think multiplicatively, okay? So as we can clearly see, right, 6 times 2 is simply going to equal 12. That balances the hydrogens over here of 12. Next, and really lastly, we can balance now the oxygen. That's the only element that's left in this reaction. Now this gets a little harder because oxygen is kind of everywhere, all right? So why don't we take this piece by piece, and we're going to write the totals down and create like a little simple math equation. So watch. How many oxygens are in glucose? Well, you have 6, right? Okay, great. Plus now. How many oxygens are there in an oxygen gas molecule? Well, you have 2. Okay. Somehow that has to equal now. How many oxygens do you have here? Now, you must include this coefficient. Once you place that in, please include that as a total. Do not write down 2 oxygens now, because you don't have 2. You technically have 12. 6 times the 2. Okay, so you have 12 oxygens there. And then same exact idea here. You have 6 multiplied by the 1. So you have 6 oxygens in the water molecule. Now, if you just take a look and take a step back, obviously this math doesn't work, right? There's no way 6 plus 2, which is a total of 8, balances 12 plus 6, which is a total of 18. So this is not a true mathematical statement, okay? So what we have to think about is we now have to think about, where do I place this variable of x, right? And what you want to think about is, should I place the x here? Should I place the x here? Should I place it here? Should I place it here, okay? If I place it here, that means I would put the x next to the 6. If I place the x here, that means I would place the x next to the 2. Okay, if I place the x here, that gets a little more complicated. You probably wouldn't even want to do that anyway, but it would go there, etc. Okay? Now, is there one place where I can place this x where it will just affect oxygen's value, just oxygen? What do you think? Right. Did you say here? I think you did. That would be the right place. See, if you take that and place, let's say, that oxygen now, let's say, you take that X and you place it over here. The problem is it's going to then affect the number of carbons, the number of hydrogens, and the number of oxygens. But you already balanced the carbon and hydrogen. Why would you want to do that? Right? You don't want to do that. So let's place that X now next to the oxygen gas molecule. And the reason why I'm doing that is because I only want to balance the oxygen. That's the only place I can place this variable. Okay? And think about it mathematically, right? This is saying some number multiplied by 2 has to now balance basically this whole equation. So just do a little math. It's very simple now, the math, right? So you do 6 plus now 2x is equal to 18, right? Minus your 6 on over. Look at how nice and simple this is. There's going to be 2x is equal to now 12. Divide out the 2 from both sides, and voila, x will equal 6. And guess what? Go back now to your equation, All right, erase this. And guess what you're going to plug in now? A 6. That's it. That's it, ladies and gentlemen. This is now fully balanced. Okay, so cleaning this up a little bit, right? If I had to just get rid of some of these lines, this would be now the fully balanced equation for this combustion reaction. Okay, that's all there is to it. Thanks so very much for tuning in. I really do hope that helped. If you can, help us out. All right, like, subscribe, even tell some of your classmates about our channel. We got thousands and thousands of videos, not only in chemistry, but physics and mathematics as well. We got a lot more coming. All right, we'd love to help you out with more stuff. Check us out.